All right, so let's learn some new terms. Positioning and terminology related terms. So the first thing we want to learn is some basic general terms we use in the field called radiography. So radiography is the field of study that deals with producing something called a radiograph. What in the world is a radiograph, right? A radiograph is a recording of radiation which has passed through something, some person in this case. Okay. So we've got a device called an X-ray machine or X-ray tube. If you've heard about if you've been with me for long enough, we know we call it an X-ray tube. It produces something called X-rays. Those of you who've been with physics, who've been through physics with me, what in the world is an X-ray?
It's the same as a radiographic image, right?
So no, sorry. I mean, from a physics standpoint, what are X-rays?
Oh. Is it rays that pass through?
They're a type of energy. Good. Are they a type of energy similar to anything else that we deal with? What kind of thing are they? Come on, physics people. They're electromagnetic waves, right?
That was just the last chapter.
They're photons of light, right? That's what X-rays are. They are, so people who haven't heard this before, X-rays are a type of light, okay? Now, you have light, and you know this even before learning about X-rays. You know there's some light that you cannot see, okay? There's infrared light. There's ultraviolet light, right? But there's also all this beautiful visible light that we can see, right? X-rays are a type of light that we cannot see. They are more energetic, higher in energy than ultraviolet. You know ultraviolet because that's the one that gives you your sunburns at the beach and stuff like that, right? Gives you a nice tan. X-rays are like that, okay? They're the same type of thing as light. They just have a higher energy. And the important thing about X-rays, which makes them different than visible light, is that X-rays can pass right through the body. They have such high energies that they can pass through the body, okay? Where a visible light would cast a shadow of like just the outline of your hand or something, right? If you shine a light at your hand on a wall, you can make shadow puppets, right? The X-rays will pass through the hand. In fact, that's how the guy who discovered them, Wilhelm Röntgen, that's how he figured out that there's something special going on here. He turned on his little machine, among other things, the other tests he did, he turned on his little machine and noticed that when he went to cast the shadow of his hand on some fluorescent light up cardboard, he noticed that he could see the bones of his hand as a shadow, okay? Meaning that the X-rays could pass right through the tissues of his hand, but not pass through the bones. The point about X-rays is that they can pass through the body, and importantly, they can expose film, okay, like visible light can, okay? So these X-ray films up here, there is no, aside from the size of the film, there is no difference between that film and the film in any old film camera. Okay, it's the same type of stuff. It's photographic film. Okay, X-rays can expose photographic film. Nowadays, we do all our exposures on digital image receptors, but the point originally was that X-rays could expose film like visible light could, but X-rays can pass through the body. So now we can take a picture of the inside of someone's body. Okay, we can't see everything. We can see roughly 4 or 5 different densities, 4 or 5 different types of structures, right? We can see gas, we can see fat, we can see muscle, we can see bone, and if they have metal, we can see metal, right? So 4 or 5 different things, okay? Because X-rays can pass through the body, because they can expose photographic film, we have this field called radiography, where we take and create pictures of the body. Recordings of radiation are what they are. That recording of radiation is referred to as a radiograph. So those are radiographs. A lot of times we call them X-rays, right? Which is why when I said what's an X-ray, I think I got an answer that dealt with that. But they're radiographs. That's the right term to use for them. So we'll try to practice using that term. Radiographs used to be primarily produced using X-ray film or photographic film like that. So those are film X-rays. But modern times we deal mostly with digital radiographs, which are the most common type of thing now. Now there's different ways to produce digital radiographs. We'll do an entire module on digital radiography. If you've done it with me, you know that it's a interesting module. But that's the deal. Radiography is the field of study. Radiography is embedded within the field called radiology. Okay, so radiography is just producing X-ray films, producing radiographs. But there's a bunch of other stuff in the field of radiology, right? There's computed tomography, CT scanning, MRI, magnetic resonance imaging, there's nuclear medicine, there's interventional radiography, there's a bunch of other stuff going on. Radiography is one little piece of the radiologic science. We make radiographs in radiography. We refer to the steps that we take to produce one of those radiographs as a radiographic procedure or examination, right? You know, there's a number of things that you, if you've done this before and taken an X-ray, you know there's a number of things that you do to produce what we'll call a satisfactory radiograph. I don't think many of those are not very satisfactory, but I'll point to them to indicate satisfactory. There's a number of things you do to make something look like that. Do you notice, like, roughly speaking, all three of those, aside from different, you know, darkness, brightness, they're looking at, you're looking at the same thing, right? The chest on all three of those people, and they're roughly speaking are positioned the same. They have a lot of the same qualities, even though those are three different X-rays, three different radiographs, taken at three different times on three different people, right? With three different X-ray techs performing the studies, right? But you're still producing three very similar radiographs. And the one shown on screen here, very similar to those three, right? All four of these were taken by completely different people, different times, different, you know, with different equipment, but they all produce very similar radiographs. That's because we have a procedure that we follow called the radiographic procedure, okay? That's the goal of this module, is to teach you how to do the radiographic procedure to create chest X-rays. All right, now that you've got that, some general terms, let's move on and talk about positional terms in the body. The first thing to learn is everything we talk about positioning-wise deals with anatomic position. So right now you're being shown with this person, you're being shown anatomic position. They're standing in anatomic position. So the patient is, we say that they're erect in anatomic position. They're facing toward you. That means their left and right is flip-flopped to your left and right. So their left is on your right is on their left, right? So it's backwards, really. That seems trivial and easy, but I promise you it's going to be difficult as soon as you start to deal with it, even though it might seem trivial and easy right now. They're standing, facing you. Their palms are facing forward. So notice the position of the hands. Palms are facing forward. Their feet are roughly shoulder width apart and toes pointed straight forward. Okay, this is what we'll call anatomic position. Now in this position, everything that's facing towards you is the patient's anterior. Everything that's facing away from you is the patient's posterior. We'll also give different names like ventral and dorsal to replace anterior and posterior in certain circumstances. But right now, anterior means front, posterior means back. Everything you cannot see is posterior on this patient. Now there's some small little caveats. The top of the foot and the bottom of the foot are not facing you or facing away from you, right? They're facing up and down, okay? We call the top of the foot the dorsum of the foot, and the bottom we call the plantar surface. Plantar, like plantar, but with an A at the end. Plantar. So you probably heard of like plantar fasciitis, right? That's a pretty common medical condition. It's to deal with the bottom of the foot, the plantar surface. All right, so you have dorsum and plantar surface, everything else anterior and posterior. And the hands get their own special stuff too. We call the palm of the hand palmar, and the back of the hand dorsum, the dorsum. Dorsum of the hand, palmar surface of the hand. Okay, so the palms of the hands, soles of the feet have their own special names, and the backs of the hands, tops of the feet have the same name, dorsum, or dorsal surface. Okay, so that's our anatomic position. We will then use anatomic position to divide up the body into in roughly three, maybe four interesting ways. Okay, we call these the body planes. Um, if you were going to tell someone what a body plane is, not name them, but describe what it is, what would you say? I know what I say, but I've done this for a long time. So what would you say? Marco, what would you tell somebody? They go, "What's a plane of the body?"
That's type of side
What is the, like, for example, let's look at one of these, and I'm gonna circle back around to you. Okay, I want an answer from you. So let's look at the greenish one here. Okay, the sagittal plane of the body. So let me give you what I call a plane of the body. I call a plane of the body an imaginary two-dimensional sheet of paper that divides the body up into some interesting way. Right? We've got four different planes. Okay, one of them is the sagittal plane, the green one here. So Marco, tell us something about the sagittal plane.
divides the body
In half, in what way?
from top to bottom.
Top to bottom, and making a left side and a right side. Yeah? Divides the body in half from left to right. Now, to be specific, the mid sagittal plane running right down the midline of your body divides you left and right. Now, for the most part, have you guys anybody played with those? I know there's apps that you can buy that like take half of your face and then basically mirror it to the other side of your face in a picture. It makes your face look kind of weird, right? Takes the right side of your face and puts it over on the left, so you got two right sides making up your face, and you look weird, right? But for the most part, you look the same from left to right, right? If you split me right down the middle, I've got an eye on one side, eye on the other side, an ear on one side, ear on the other side, roughly the same shape of face, right? My mouth goes to as far to the left as it does to the right, my nose too. We have what's called bilateral symmetry, right? I've got an arm on the left, leg on the left, and an arm on the right, and a leg on the right, yeah? We've got bilateral symmetry. We look the same from left to right. Again, not exactly the same. Go download one of those apps that splits your face and copies one side to the other, and you'll see that you don't look exactly the same from left to right. But for the most part, for argument's sake, you look the same from left to right. You have, as what I just said, bilateral symmetry. So that means the mid-sagittal plane is special. It's a plane of the body, the one shown in green. It's the plane of the body that divides the body up equally. It's the only equal division that you can make to the body, left and right. Okay? The other planes make an attempt at equal divisions, but can't. Okay? For example, the next one down on the little bullet points is the coronal plane. The coronal plane is the plane of the body that divides the body up into front and back. Now, you can put this coronal plane at any position throughout the body, okay? And it still divides the body up into front and back. You can get pretty close even to dividing the body up into equal front and back. If you just extend a line down from my axilla, my armpit, straight down, you can roughly divide me front and back. And there will be about as much in front of the plane as there is behind that plane, right? The mid-coronal plane is what we'll call that, sometimes called the axillary plane. Again, shown in this purple color here. But you know by now that you cannot divide the body up into equal divisions except for the mid-sagittal plane. So this is just a division in front and back, not necessarily equal. I'm going to skip oblique and go down to the axial plane. I actually really don't like the word horizontal or axial because they imply different things in radiography. We call this the transverse plane. Remember all three names. Transverse, horizontal, and axial all mean the same thing. Transverse is really the better term. The transverse plane divides the body up, tops and bottoms. And that transverse plane can be put anywhere along the body. You know, down at the feet and ankles, all the way up higher. Now, we'll use these planes of the body to help with our positioning, but you should know that some imaging modalities, some ways of getting images of the body, produce cross-sectional images that show you things using these planes of the body. Okay? For example, this plane of the body here, we're looking at a MRI of the head, okay? And we're looking at the head basically from top down right now. And as they've sliced, we're looking at a slice of the head from top down. We're looking in the transverse plane right now, okay? They've cut the top off of the head, right? And we're looking down on that, okay? Whereas this here on the left, we're looking at a sagittal plane of the body. So there's a slice gone right through the body, right? We're taking a slice of the body. Now these images that you see, these MRI cross-sectional images, usually represent something like a 1 or 2 millimeter thick slice of the body, okay? You can tell the software in the computer how thick of a slice you want to look at, okay? And you can also move through the body from left to right, from front to back, from top to bottom, right? The MRI and CT allows you to view the body as a cross section in many different planes for one. So CT allows you to get the three: sagittal, coronal, transverse, but MRI will allow you to make a cross section along any plane of the body. We typically use just those three, but MRI allows you to achieve a number of different weird angles and planes. This is being shown the sagittal plane on the left. Can you identify what plane is being used on the right? We've covered maybe not maybe mid-coronal, right? But coronal, right? It's a coronal slice, okay? Ultrasound students do the same thing too. They take their transducer, they hold the transducer, they'll hold it in the sagittal plane, they'll hold it turn it sideways, hold it in the transverse plane, and they'll also come to the side of the body and come through in the coronal plane too, okay? They do the same planes of the body that these other tomography modalities use. A tomogram is what you're looking at right now. Okay, so we do radiographs, right? Which are these things, okay? These are tomograms. Tomograms are cross-sectional slices of the body, okay? In fact, the word CT, the term CT means computed tomography. A tomogram is a cross-section. Okay, moving on. All right, one more time with anterior and posterior. So there you go, anterior, posterior. Zoom in a little bit, and we'll notice that they've used slightly different terms. Well, they have the anterior, posterior, but they also include in parentheses, under anterior, they include the word ventral. Ventral, taken from the root word ventro, meaning, what's ventro mean? Think about the ventricles in your heart. What's the ventricles pump, but that's not where they got their name from. Their name is ventricle because they look like a little tummy, a little belly, okay? The word ventro means belly, and the words ventricle means little bellies, okay? So you can think about it, right? The heart dumps the blood down into the ventricles, right? Fills those bellies, right? That's why they're named ventricles. The front of your body is called the ventral surface because you have a tummy in the front, okay? It's your tummy. Ventral surface is the front of your body. Dorsal surface is the posterior. So it's posterior surface or dorsal surface. For example, we would say the back of someone's body is the posterior surface, but if we laid them down on a table, we'd say that, and they laid on their back, we'd say that they are in the dorsal recumbent position. We don't say posterior recumbent. So we use these different terms in different circumstances. And there's the foot here, right? Dorsum of the foot, plantar surface of the foot. Top of the foot, bottom of the foot. Okay. Next, we're going to talk about some other general body positions. So we've covered anatomic position, patient standing, palms forward, feet are shoulder width apart, everything facing you is anterior, everything away is posterior, and we made 3 planes of the body from that. Moving on from that now, we're going to talk about general body positions, positions that you'll put the patient in. And let's actually crack open the text for just a second here. Let's go to chapter 2. I'll get the page for you in just a second. All right. So you'll notice as you read through, if you go to, hey, let's start at the beginning, right? So if you go to, chapter 2, page 69, you kind of flip through some pages, just flip through a few pages after page 69, you'll notice you're going to learn a lot. It's going to show you some things about the body, some structure. It's going to tell you all about the body. But then now go to page 90. So in each of these body sections, for example, chapter 2 is the chest. In each of these body sections, I'm going to pause this recording.